Starting Module 6 and working our way into 6.1, we're going to work with the expressions and equations. And the module essential question is how can you use algebraic expressions and equations to solve real-world problems? So we're going to look at lesson 6.1, which is algebraic expressions, lesson 6.2, one-step equations with rational coefficients, lesson 6.3, writing two-step equations, and lesson 6.4 is solving those two-step equations. As we get ready for moving into the lesson 6.1, the 7.EE.1 standard, the expressions and equations, a couple key vocabulary terms that we have here. We have the coefficient, the number that is multiplied by the variable in an algebraic expression. Coefficient is this guy right here, the number that is multiplied by the variable. If you haven't noticed, one of my cats, Frank, has joined us. He's laying up here, right here. Say hi, Frank. There, see, there's Frank. So he's just kind of chilling out there. Okay, so when we look here, we talked about the distributive property in the background information. So they just give us another example, 2 times A, so 2 times A, plus 2 times 7. So we have 2 times 7. Like terms, we don't have any, so the best we can do is just create this expression, 2A plus 14. Moving down to the next standard, 7.EE.4a. EE is expression and equations. Solve real-world problems leading to equations of the form Px plus Q equals R and P times X plus Q, which equals R, where P, Q, and R are specific rational numbers, and then solve that. So basically you're looking at the two different forms on how this one's the factored and this is the simplified one. So we have the equation. We look here, the difference between an equation and an expression is that an equation, 3x plus 4 equals 12. So we kind of highlight that root word, equal, equation, it has this. An expression does not have that information there, okay? So that expression, so that's the big difference between these two, okay? And when you look at that, if you're asked to write an expression and you write an equation, that's wrong. So pay attention to the wording and what it is that you're being expected to write. So I've highlighted the information here in the example that they've given us. Rental is $12 for the first hour, $9 for each hour after that. They have $50. How long can they rent it for? So it's kind of what I call write what you see. Write what you see. Okay, so I have $12 for the first hour. So there's $12. And is a addition. And then $9 for each hour. So that's a unit rate. So that's a unit rate going back to our previous modules. So we have the 9 times however many hours that it is, okay? So where X is the number of hours after the first hour, so they define that for us. So we set the equation up, okay, because we have $50, so 50 equals 12 plus 9X. So they get through and they're going to do some equation solving here, which you guys are going to learn about through the modules. And they come down and they show the answer is they can ultimately rent for 4 hours. This is the part that we're going to work on through the module to help. Getting started in lesson 6.1, you're going to learn how to add and subtract linear expressions and to use the distributive property to expand those expressions, and some understandings that you're going to have. An algebraic expression is another way of representing the information given in a verbal expression, a word problem. The commutative property of addition allows the order of add-ins to be interchanged so that the terms can be combined. So in the background information and the distributive property, we use that. The distributive property is used to combine like terms of the expanded and expression. And when factoring an expression, place the greatest common factor outside the parentheses. So here the essential question is, how do you add, subtract, factor, and multiply algebraic expressions? And we're going to be working with standard 7.EE.1. In example 1, I've highlighted the important information for the word problems. Jill, 25 plus $10 per hour. Kyle is $18 plus 14 per hour. Write an expression for hiring both of them. So they go ahead and down, and if you follow what I'm asking you to do, write what you see, okay? So I see 25 plus $10 per hour. So for Jill, here's the 25 plus the $10 per hour. So we use the H for the hourly rate. That's our variable, okay? So, well, the H is for hours right here. And then the $10 is the hourly rate. And we do the same thing for Kyle. So there's a fee that Kyle has. And then it's the hourly rate is $14 for every hour that he works. So then the H is over here. So I write what you see. Now what we're going to do is we're going to combine them, because you're the company. So it's your perspective on what you're going to pay Jill and Kyle. So that's why we're going to combine those right here. So we have Jill's, which is the 25 plus 10H, and then we have Kyle's, which is the 18 plus 14H. They use the commutative property to move things around. Okay, so they've combined the like terms. If you don't recall that, go back to the background information that I combined, and I talk extensively about like terms. But 25 and 18 are like terms, and the 10H and the 14H are like terms, because these both have the H variable in them. These do not. So 25 plus 18 is 43. The 10H plus 14H is 24H, because 10 plus 14 is 24, and then we just use the common term of H, and that's right here. So the company will pay $43 plus $24 for every hour that Jill and Kyle will. So I'm going to combine my like terms. So I have, this one has the X and this one has the X. So negative 0.25x, and this is going to be a minus, because really what I'm doing is I'm multiplying through here. So this is going to be minus 1.5. So I'm going to subtract, and then my other like terms are the negative 3, so minus 3. And now again, what's a negative times a positive? So that's going to be a negative 1.4. Now why is that? Well, really what I'm doing is I'm taking a addition, and then if we remember additive inverse, I could do adding a negative, and or I am subtracting a positive. So if I take there's a 1 in front of here, if I multiply anything by 1, I get the same thing. So negative 1 times 1.5 is negative 1.5 x, and then a negative 1 times a positive 1.4 is a negative 1.4. So now if I go and combine my like terms, negative 0.25x minus 1.5x, that's going to be negative 1.75x, and then negative 3 minus the 1.4 is going to be negative 4.4. We talked about the distributive property somewhat already. And here they go through about also calling, the simplifying or the expanding is another term that's used. So you take the 3 times the x, and that gives you 3x right here. And then you take the 3 times the 5, so that's what you're doing there. So this is the interim step, 3 times x plus 3 times 5. And then you go ahead and do the math, so that's 3x plus 15. And they have another example for you going down through simplify. So you're going to take, you have the 5. This is a negative 3. So negative 3 times 7 is negative 21x, because 3 times 7 is 21, and that's a negative. Now this is a negative 3 times a positive 8. So if you remember, a negative times a positive equals a negative. So negative 3 times a positive 8 gives us a negative 24. What they've done here is they've done the additive inverse now. So if you recall, with the additive inverse, if we subtract a positive, we can add a negative. So by doing that, it allows them to rearrange your terms. The other way we could do that is we could just simply take 5 minus 24 minus 21x, because we know that 5 minus 24 is going to be negative 19, and then minus 21x. And that would be our equation. So here in example B, now they're just using fractions, okay? They're still using negatives, so we have to remember that. So a negative times a negative is a positive. If we take 1 times 3, that's 3, and 3 times 4 is 12. So 3 over 12, and then they simplify that, so that's 1/4. They do the same thing again. So we had done this. Now we're going to do this one. So 1 times 2 is 2, and 3 times 3 is 9. You have a negative times a negative, so that's a positive. And then the last one you're going to do is this. So to help you out, write that over 1. 1 times 12 is 12. 3 times 1 is 3, so 12 over 3, and that's 4. But it's a negative times a positive, so that's why that's a negative 4. Then from here we go ahead and we start combining like terms. So we have a negative 9a, we have plus 2/9a. If we go through the math, we get negative 8 7/9. And then we have a quarter plus, so we got a positive quarter minus 4. They did the additive inverse. Okay, so that becomes subtracting a positive is adding a negative. And then that way they went ahead and did the math and they got negative 3 3/4. So pretty complicated here, but if you're putting all your steps together back from Unit 1 with your number sense, your multiplications of additions and, multiplication of positive and negative numbers, working with your fractions. That's why we work with you on your fractions, so that you can see this, because it's going to be more complicated than this. So if I do number 5 here, and I'm going to do, this is over 1. So 2 times 6 is 12. I'm not going to simplify this. You guys can do that. And 3 times 1 is 3. So that's 12 thirds E. Okay, this is positive. So now we're going to add. So 2 times 9, I'm going to put that over 1 again to make that a whole number into a fraction, is 18. And then the 3 times 1 is 3. And that's an F. And then I'm going to, this is a positive times a negative, so I'm going to subtract 2 times 21, and put that over 1. That'd be 42 over 3 times 1 is 3, and that's G. And that's where that stops, okay? And then I would subtract 7F. So you have like terms here, okay? E is by itself, G is by itself, so then you would go ahead and simplify your mixed fractions and then reduce it as far as you can. All of these problems follow that same suit. The more practice that you do, the better you'll get. For this section, I'm going to save the algebra tiles for in class, but what I'm going to do is I'm going to show you how you're going to factor out your common forms, okay? So you have 4x plus 8. Okay, so when you look at that, what number goes into the 4 and to the 8? What's the greatest number that will go in there? Well, if you remember from your multiplication, it's going to be 4. Okay, 4 goes into itself, and 8 and 4 goes into 8. So how we do this? Well, once you figure out what that number is, and it's going to be 4, we're going to write that down. We're going to write a parenthesis. 4 goes into 4x one time. So really what happens is that 4 divided by 4 leaves you with 1, right? So you're left with 1x. 4 goes into 8 twice, okay? So you're left with 2. And then you use this sign and you place it right there. We have just now factored, okay? And if I clean this up, this would actually be 4x plus 2. So that's one example of factor. Let me go ahead and do 1 or 2 down here, and we can kind of look at this. So when you look at 2x plus 2, what number goes into that? Well, it's evident that 2 goes into it. So I'm going to take 2, okay, because you're going to divide by 2. So I'm left with 1x, and then if I divide this by 2, that's going to be 1. So now if I rewrite it, 2 is x plus 1. And if we went ahead and simplified that, this 2 times x is 2x, and then 2 times 1 is 2, and we use the addition between. So we're right back to where we were. So that's what factoring is. So if we do this one over here, 4 and goes into 16 also. So 4 is factored out. I'm going to start skipping this step of writing the 1x because all I'm saying is that we have 1x there. Because if I divide this by 4, I'm left with 1 because 4 divided by 4. Okay, so that I'm left with x. And then 16 divided by 4 is 4. And then I use this sign. If this was a subtraction, you would use a subtraction. 4x plus 16 when it's factored is 4 times x plus 4. You have the guided practice down below, and you have your independent practice, so please go ahead and use that, and hope this helps you out.